Assalamualaikum and good evening. My name is Muhammad Luqman. So now I would like to present about concept and principle of pre-stressing that are being adapted in prestressed concrete. The concept of pre-stressing has been practiced since years ago, where ropes or metal bands were used to wound around a wooden stiff in the process of forming a barrel, as shown in the figure. The bands will be under tensile pre-stress when they were tightened, and compressive pre-stress between the stiff will be created so then they can resist tension produced by internal liquid pressure, which is from the water filled in the barrel. In simpler words, the bands and the stiff were both pre-stressed before they were subjected to any service load, which brings the concept of pre-stressing to construction work, which is the prestressed concrete. Figure shows a simply supported beam of plain concrete carrying a load. As the load increases over time, the beam will deflect slightly until it fails abruptly. As we all know, when a beam is under load, the bottom part of concrete is where the tension zone occurs. This zone will try to elongate after external load is applied, which will then cause cracks on the beam because the characteristic of concrete which have low tensile strength. To avoid the crack, steel bar is used as reinforcement as it can provide higher tensile strength. This is the commonly used reinforced concrete structure. However, the cracks also can occur when the structure have larger beam span, where external loading is much higher. The concrete will crack before the rebar can take any of tensile stress from the member, as the concrete is brittle. The solution to this problem, which is deflection in concrete member, is by using the principle of prestressing, which is already being adapted in prestressed concrete. To produce prestressed concrete, higher grade of concrete must be used, as the stress are really high in section due to prestressing. As shown in the video, the tendons will be stressed within the elastic limit by pulling them at both ends of the structure, and tensile stresses will be developed. After releasing the tendons, it will try to go back to its original condition from its stretched condition. However, due to the locking of the tendons at the end of the structure, it cannot go back to its initial condition. It will always squeezing the structure along with itself, which will develop compressive stress in that zone. As the bottom part of the structure has higher compressive strength due to the prestressing of the tendons, the beam structure will be deflected upwards. After external loading is applied, the amount of tensile stresses developed, which is the external forces, is counteracted by the compressive stress developed, which is the internal prestressing force in the structure due to the prestressing. And therefore, the whole structure will become compressive and no tensile stresses are remaining in the structure.
Assalamualaikum. My name is Ahmad Afiq Hakimi bin Roslan. So I'm going to present about the procedure to construct prestressed concrete. The first step is the preparing the mold. Before any of the production process phase is applied, the mold must be first prepared. For the production of one prestressed beam, the usage of concrete can be plentiful, where the quantity of concrete can be above 4 meter cube. Therefore, the molds that are used for purposes like this must be very strong, and that is the reason why steel molds are used in the video. This video shows the element of mold. Second step is the placement of reinforcement. In every concrete element has the traditional reinforcement that always must be present no matter which method of prestressing is applied. In this method, the wire for prestressing are placed to the mold together with the traditional reinforcement. Next is the prestressing. This type of production uses long line method of prestressing with parts which one end of wires is strongly connected to the abutment by an anchor, while the other end of wires via anchor spindle is connected with hydraulic jack. The wires are tensioned by the hydraulic jack to sufficient prestressing force, so the wires remain tensioned and the casting of concrete can begin. In this section, the casting of concrete begins. The quantity of concrete needed to make an element depends on element dimension and specified. Casting of concrete must be performed with no interruption. After the concrete has been placed into the mold, compacting of fresh concrete must be performed. When the concrete achieves the desired compressive strength, the connection between wires and anchors is released and prestressed element was made. After all the procedure has been completed, the next step is to remove the mold. The mold can be removed from the concrete only when it has achieved sufficient strength. Removal must be taken with care in order not to damage the element. It is also recommended to remove the mold after concrete has achieved maximum compressive strength, and that is 28 days after the casting of the concrete. The last step after remove the mold production has completed, then it is time for storage phases.
Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Muhammad Rizwanti bin Muhammad Aliti. Now I'm going to present about the precast concrete is preferred compared to conventional cast in situ in construction method. This slide is based on some of the sources that I've made to verify the facts. Before that, I'm going to give a short brief about precast concrete and conventional cast in situ. Firstly, precast concrete is poured and molded over rebar or wire and then cured off-site. This involves pouring concrete into pre-made molds and then cure under ideal conditions within the manufacturing plant itself. Next, cast in situ concrete is casted into forms on the building site. It offers unlimited possibilities to the designer for any shape formations with a limitless selection of surface textures. However, why it is said that precast concrete is preferred compared to the conventional cast in situ? So let me see here. There are some reasons in the different terms to evaluate the precast concrete compared to conventional cast in situ in constructions. Firstly, in casting. In the precast concrete, elements are manufactured in a controlled casting environment, and hence it is easier to control mix, placement, and curing. While in the cast in situ concrete, such as column, slab, and walls, these elements are casted on site in the open environment, and hence it is difficult to control mix, placement, and curing. Next, for the quality control can be maintained easily in the precast concrete, while quality control and maintenance is difficult for conventional cast in situ. Next, in terms of cost, precast concrete is cheaper form of constructions if large constructions are to be constructed, while in situ concrete is cheaper form of constructions for small structures to be constructed. Next, requirement of worker and machinery. In precast concrete, it requires less labor and only a small amount of skilled labor are required at the construction site. While For the conventional cast in situ, more labours are required and skilled labours at the construction site. Next, for the strength, high-strength concrete can be used because it is in controlled conditions for the precast concrete, and for the cast in situ, it will be difficult to use high-strength concrete as it depends on the site conditions and resources available. Lastly, the precast concrete use less time compared to cast in situ.
Assalamualaikum and good evening. My name is Muhammad Ikmal Shafi and I would like to talk on my part about how precast concrete construction can contribute towards reducing carbon dioxide and global warming issues. Okay, firstly, what is precast concrete construction? As we all know, it is a construction product produced by casting the concrete in a reusable mold which is then cured in a controlled environment in the manufacturing plant. After finish, we can start to transport to the construction site and lift into place. There also a greater control over material quality and workmanship in a precast plant compared to an in-situ casting. It can be performed on ground level, which helps with safety throughout the project. Over the year, we can see that precast concrete has become more relevant in the construction industry, as they believe it can lead to 52% of waste reduction and 70% of timber formwork reduction. Okay, let's see how precast help reducing carbon dioxide and global warming issues. First, in precast, it uses less concrete than an in-situ alternative. It is up to 30% saving in the volume of concrete when it comes to made up the structural element. Hence, it will reduce the cement production, which is the major ingredient in concrete. The second one is air quality is controlled. In precast manufacturing plant, dust from cement silos, mixer operation and sandblasting can be minimized. Unpaved road dust is addressed and welding operation for the reinforcement steel are adequately vented. The last one is precast itself is very environmental friendly. The carbon that is produced during the manufacture of cement is offset with minimal maintenance costs, lower heating, and concrete reabsorbing up to 40% of the carbon over the structure life. Energy use is being monitored and controlled. Heat curing is in a closed system also. Excess concrete is effectively used, costs are minimized, and waste product is crushed into reusable road-based materials. Due to rapid economic development that happen nowadays, which consume large amounts of resources and degrade the environment, so many of construction industry nowadays tends to use the precast method as we can control the concrete wastage that usually happen on site. Let's see one example of previous study that have been made before about the precast method. The study has been conducted in 2015 by Dong, Jaelun, Chu and Pon about comparing carbon emission of precast and cast in situ construction methods. The study is based on a case study of a private residential building in Hong Kong. In the study, it highlights about the adoption of precast concrete which can reduce the carbon emissions. The carbon emission of 1 meter cube cast in situ concrete is about 629 kilograms of CO2. It also states that for 1 meter cube concrete, The precasting can lead to 10% reduction of carbon emissions, and adoption of precast facade also can reduce 2.1 kg of CO2 per meter square floor area. These are few examples of statistics that being stated in the study. Based on the three graphs, we can see that precast method contribute lesser amount of CO2 compared to the in situ casting. As we all notice nowadays, the rapid economy development consume large amount of resources and degrade the environment. One of the primary concerns of environmental impact is climate change, being most likely attributed to the emission of greenhouse gases. Due to the statistic, it is really proof that precast concrete method can contribute to the reduction of carbon dioxide and global climate change. Thank you.